Dumelang, hu itahane, sawubona, molo. I hope you're ready for this. We have an hour and a half, and I hope you have a coffee or some drinks or some snacks with you because we will be covering quite a bit of material. Now, if you have questions, you are welcome to ask that after the session. But also we will be sharing the slides so that you can go back because it's quite a lot of material we will be covering today. And we're also available for questions after the workshop. You can email us if you have any questions regarding this session. So today, we'll be mainly looking at what skills do you need to survive in research. And I will be giving you a brief overview due to the time limit. Now, besides, doing your literature review, and knowing how to do your experiments, which techniques you will be using, and also how to present oral presentations at conferences, and also how to compile a poster presentation. There's a whole lot of other skills one needs to attend. Now, the UNISA provides a lot of different workshops, and I would really highly recommend that you attend each one of those. There's also various, papers on research skills available that you can look at on Google Scholar, or also Nature Careers is very useful. Especially there's a column in Nature called Nature Careers column. And there's very useful articles in that covering, tips for your career and future, etc., etc. Also, there's various, YouTube videos available. So I would highly recommend that you have a look at all of those to enrich your knowledge, because we can only cover a certain amount of materials. So what we will be looking at today, so we will be covering a little bit of research methodology or different types of research design so that you can apply the appropriate research method relevant to your field. And why is this important? Because when you one day write up your paper for publication and you submit it to a journal, in your method section, or already sometimes people also include it in the aims section, depending on your field, you have to describe what type of study this is. Like, for example, the aim of this descriptive study, or the aim of this prospective clinical trial, or the aim of this preliminary research, or the aim of this applied research. One needs to define what is your research, what type of methodology you, or what they call also the research design. So that's important to highlight that in your paper so that people can understand the approach of your work. Then we will be also very importantly looking at critical thinking. This is important. And whenever you look right through your research career, when you start formulating your research question, when you look at literature, when you write up your work, when you analyze your data, when you write your discussion, you always have to critically think of each of these components of your research. For example, when you think about your research question, you have to critically think, is this doable? Is it novel? Will it be publishable? Will it be fundable? Do you foresee a future for yourself in this field? Also, for example, when you're planning your experiment, you have to critically think, is this methodology that I'm using correct? What does the literature state? Do other researchers use other types of methodology? And what is now novel in this field? And if other researchers use a certain approach to a study, it's not that it's, the best one. You have to read widely, critically think, is this really the right approach? How can I improve this? Is there other novel techniques that I can use? Is there a combination of techniques I can use to answer a specific question? Let me give you an example. For example, if you are looking if you are having a sample and you want to look at, for example, you are doing an environmental toxicology study, and you have collected, for example, nail samples for participants or urine and blood, and you want to understand if these participants have been exposed to toxic environmental contaminants. Maybe they're living near a mine, or maybe there was some hazardous spill, and now you want to investigate that. Then you need to decide which technique, you need to critically think, which technique will be is available to me that I can access. What is the cost of the technique? Is there someone that can assist me with that? Is it available here? Is it available in another country? How do I plan to get access to this? And how, for example, how can I put all this together to get a good profile of the toxins that my subjects or my participants are being exposed to? Now, one also has to think some techniques are more sensitive for certain elements, whereas other techniques are not so sensitive, then one can use a combination. So critically thinking is very, very important. Also, when you're writing up your results, nowadays, papers can combine results and discussion section, and then people make the mistake by only reporting on the results, and they don't really interpret what does this results collectively mean. Are the individual results, are they interlinked? Does one result have an impact on another result? How do I discuss this? What is the implications of my study? If it contradicts previous research, why? Then you need to critically think about this. Problem solving. Also, if you run into a problem with your experiment, don't go and sit there in the lab and feel sorry for yourself and panic or stress. This is not good. You go to your supervisor, you ask, I've run into this problem, how can I solve it? And you also critically think about how you can solve this experimental problem. Maybe I can, change the angle of my experiment, or I can tweak my hypothesis a bit to adapt. We'll be doing some examples of that later on. Also, the literature review will be also covering that. How to look for papers. I've done this already in the previous session, but for those of you who have not attended, we'll be looking at that again. Data analysis, I will not be going into detail about that because there are workshops offered on that, but it's important, very important for you to have a data management plan. For example, how are you going to share your data? Do you have sensitive data? For example, are you working with patients, or are you working in a type of social sciences environment where you provide people with questionnaires and they provide sensitive information? Then you have to think about how you're going to protect this information, with whom you're going to share it. Are you going to share it on a Google Drive? How safe is this? Can people get access to this, etc., etc.? Then also, when you have captured your data, it's important to back this up. Very important, because laptops can go missing, they can back up, and everything can happen. So how do you organize the data? How you clean it up? Okay, is there outliers? How you're going to treat that? And then also have a plan. Don't just go to the statistician and say to them, okay, I have this data and I want to do this and this and this statistical analysis. Decide. Obviously, we'll start off with descriptive statistics. So you will summarize your data and means and standard deviations and standard errors. Then you also have to think there's a difference between a standard deviation and a standard error. Your data has to adhere to certain specifications depending on the test you do. And all of that you discuss with the statistician. And then after that, you'll go on to the more complicated statistical analysis, where you see, is there associations between variables? Is there relationships? Do they correlate? Do one variable predict another one? And also, if you have a lot of data, there may be factors or confounding variables that may be influencing the outcome, so that you also need to control for and mention. Also, you need to think about what level of P value am I going to use, because this can also influence the outcome of your data. So all of these things, how you analyze your data, need to link back to your aims. Okay, you need to answer your aims. And once you have that data analyzed, you need to critically think now, what does this all mean? How do I report it in a good manner, so that the examiner or the reviewers that are one day going to review my paper is going to understand it? For example, don't just report something like, for example, I got more bananas than apples. You have to mention I have obtained, or I got more significantly, and then you include the p-value, more bananas, and then the n value or the mean and the standard deviation, and then also then apples, and you also include that then the mean, standard deviation, and the number of samples, to be very clear in your approach of that. Also, how you summarize your data is very important in tables and figures. You show it in a figure if you want to show trends. There's something visual, and you keep it in a table if you actually want to scrutinize the data values. Also, when you're going to a conference, people don't want to look at tables. It's too much data, too much numbers. They get bored. Rather, provide it in a nice figure that can show your summarized data in trends. Always discuss it with the statistician as well. Then, scientific writing, I'm not going to go into too much detail about that, but remember, when you write, people make this mistake that just before they have to hand in the thesis, they start writing up. No, start right at the beginning, because good writing takes a lot of time. Remember, there's a lot of things that you have to cover in your study, a whole lot of stuff you have to write up. So some people make the mistake, whatever comes in their head, they write in the paper, and then when someone else reads it, it's not coherent. It doesn't make sense. The writing doesn't flow. And then when someone else is reading it, you may understand it, but someone else may not. So give your thesis in sections to your supervisor. Write the literature review, give it to your supervisor so that they can check. Is the writing clear? Can you maybe shorten it? How's the grammar? How's the English? How's the argumentation that you use? For example, do you motivate the novelty in the study and why you did it? What is then in the literature to support that there's a lack of information and that is why you did the study? So always think about these things, but there's a lot of other things to think about in scientific writing as well. But it needs to be clear, it needs to be concise, and it needs to be well structured. Time management is also very important. Plan your degree ahead. Make a plan for you in Excel, or you can use Gantt chart, or there's nowadays various research apps available. And then you note to yourself, okay, during the first month, I'm going to check the literature review. And also, don't only do this in the first month, you continually check the literature, because there's continually papers being published. So if you check the literature again, by the time you submit your thesis, your data may already be old. Someone else may have published something similar, and then the reviewer or examiner will ask you, okay, this study has been published, but you didn't mention this in your paper or your thesis. So how does your work compare to this one? So continually check the literature. Then put in, when are you going to start your experimental work, or your recruitment of participants, for example, if you're in a different field, medicine or social sciences. So plan all of this ahead. Also, very importantly, when you're in sciences, when you need chemicals for your research, plan ahead, and at least a couple of months, at least 6 months before you start your experiment, you have to check, do I have this in the lab? But then you need to order, because sometimes these chemicals take a very long time to get to the lab. Also, it has to go through a financial procurement process. It's not just about ordering stuff and then it arrives. It has to be, there's financial procedures in place, and one has to adhere to this. So time management is very important. Also, include in your time management plan when you will be writing up your work, and also think about conferences that you can attend to present the work. When are you going to publish this? All include that in your time management. Also include what skills are lacking. If, for example, if you don't know how to use a certain technique in the lab or a certain approach in your social sciences research, attend a workshop. Put that in your time management plan. By month so and so, I want to attend this workshop. Then collaboration, very important. Now already that you're starting to attending workshops, going to small events, conferences, or any events for postgraduate and students, Network with people, talk to them. Then it's good to build your network. You may never know. One day you may be in a project and then you think, I remember I met this person. Let's start a collaboration. Let's contact them, and link up with them on ResearchGate and LinkedIn and all these type of research social media stuff. Presentation skills is very important. I'm not going to delve too much into that. But this is important how you present your work at conferences. For example, if you're attending an academic type of conference, you need to know your work because people there are very knowledgeable in your field. They may ask you questions, and you may, before you go there, you already anticipate what type of questions they are going to ask you so that you prepare well and you can give a nice and full and detailed answer to whomever is asking you the question. Also, your body language is very important, how you dress, how you prepare your slides. Don't put too much colors in there. It can distract people. Prepare well in advance. Go and upload your talk. If you're giving an oral talk, go and upload it before your session starts so you don't fidget there and things don't work and flash disks are out of order before your session starts. Eye contact with your audience is very important. Some people stand and they always stare at the slides. This is not good. You have to speak to the people in front of you. Be confident and be also very proud of your work. People can sense that. Also take business cards with, or if you publish the paper, take it with you so that you can give it to paper. It's always good to do oral talks at conferences because that gives you a bit more visibility, but poster sessions is also good because it gives you more time for one-on-one contact with people, and you can also apply for poster prizes, etc. Ethical clearance, this is very important. Studies need to go through ethical clearance, and particularly if you're working with human subjects, this is very important, and start with this very, very early on. Ethics can also branch into how you handle your data. You don't want to, falsify your data, anything like that. That's very wrong. Reviewers and editors can pick up on this. Research repeatability, that's also important. How you describe your research in your method section of your thesis is important so that someone else can go and repeat it. Because if you don't describe it in detail, someone else can go and repeat it and they may not find the same result, and then they will mention, okay, but we didn't get the same result, and then they may hypothesize why this could be. And this is especially important if you're doing applied research, a research that will be developed in some kind of a product that will help society, like medicine or something. Then it needs to be very, very rigorous, the methodology and how you describe it so that other people can repeat it. Plagiarism as well. Before you submit your thesis for evaluation, check that you don't commit plagiarism. Adaptability is also a very important skill in research. A lot of different things happen. You need to be adaptable. Okay, if something goes wrong, find an alternative. Don't sit and sulk in the lab or stress yourself out. It's not good for your health. Then networking, as we already said, very important to network at conferences, meet people in your field, talk to them, talk about your research. You may get different perspective, different, ideas. Talk even to people from other areas. I once was at a physics conference. I'm a biologist, and I spoke to someone who's a physicist. I didn't understand much what was he doing, and he didn't understand much what was I doing, but we had a nice conversation, and he gave me very nice ideas to further the project that I was currently working on. Grant and proposal writing, this is also very important, how to write a proposal for a grant. At this stage, also you can start applying for fellowships to support your M and PhD studies. Learn how to write a good proposal, what to include. There's certain, for example, sometimes they will also outline what they require in the proposal. It's very important that you adhere to this, but generally, depending on the type of grant or fellowship you're applying for, novelty is important. Sometimes emphasis is placed on multidisciplinary work, so work that branches into different fields. Novelty is, again, a very important aspect. Innovation, whether there's a gender aspect, sometimes they also look at that. Is your methodology sound? How is your budget? How is your time management plan? There's some they score that as well. How is your risk assessment? Will there be any risks involved in the research, and how you are going to overcome this? You also need to mention this, but this varies from grants to grants. Self-reflection and improvement is also very important. Seeking feedback on your work, sharing your writing so that you can get feedback. If people criticize you, it's not that you are not good, it's to improve and to help you learn and grow. I remember when I submitted my first honors work, writing, it was terrible. I thought it was the best work possible, but it was absolutely terrible. And my supervisor told me straight, horrible, go and redo it. And I learned a lot from this process. So take it as a learning curve when someone criticizes your work. Resilience, very, very important. In research, you will have a lot of ups and downs. Experimental work may not work out, papers may get rejected, but it's important. There's always a lesson to be learned in this and to never give up, because if you don't do the work you are meant to be doing, who else is going to do this? For example, resilience is also, I'll give you an example later on. There was a story a while back about a person who won the Nobel Prize. They wrote a very good paper for the Nature magazine, and the Nature rejected it, said it's a horrible paper, useless. And many, many years down the line, this person eventually won the Nobel Prize. So persist. There's challenges, but there's only one way through them, and this is going straight forward. Now, let us move. Okay, we already touched on some of these principles, but I'll just briefly go through this. So let's look at scientific writing. What are the core principles of that? Remember, we need clarity in writing. We need coherence. Your writing needs to form a story. For example, when you write your literature review, you need to cover all the aspects of your study, and you have to write it in such a way that the examiner can see that you have a good background knowledge of your work, why your work is important, what was done previously, what were the limitations, and how you're going to fill those gaps. And you need to tell a story to convince the reader in such a way that when the person read it, it's clear, the sentences are nicely structured, there's flow in your document. For example, when you're writing a paragraph, you start with the topic sentence. For example, today we have a workshop on skills development. This workshop will cover this and this, and to conclude, the following workshop will follow through on this and that. So this is how you create structure in your writing. Think of the paragraph as almost like a burger. Your bun is your introductory sentence. The patty and the cheese and the other stuff is the supporting sentences that builds on the previous sentences. And then the bottom bun is like the last sentence leading to the next paragraph. This creates some kind of a flow that it reads nicely and it makes sense to someone else who may not be knowledgeable in the field who reads this. Also keep to one idea in your paragraphs. You don't want a lot of stuff in there. It starts to be very confusing. Writing arguments, learning that skill is also very important. How you structure and flow, the structuring and your flow of your article as well, or your thesis. Remember, you have your introduction or your literature review, then you have your method section, then you have your results section, then you have your discussion, and then your conclusion. Also, doing how to do the literature review well, it's very important. We'll be looking at that a little bit. Clarity in language use is very important. You don't want jargon or type of weird words like, not very proper English language. Be very careful. You have to use proper language when you are writing up your papers. How you compile your figures and tables is also very, very important. How you reference your work and keep the style consistent of the reference. Don't mix it up. Sometimes it will irritate the reviewers and the editors, and they will point out you are out on this. Ethics, we already discussed. Presentation, we already discussed that. People like to see visual stuff when you go to conferences. So include figures, graphs. For example, if you summarize your data, rather show a figure If you can show trends, it's more interesting for the audience. How you carry yourself, how your voice, don't speak too soft. People at the back may not hear it. How you pace your sentences, okay? Eye contact, your posture, what you're wearing, that's all very important. Also, when you go to conferences, think about who's going to attend this conference. Is it an academic conference or is it a other type of conference where different types of people are attending? There may be people in policy that's attending. There may be people from industry attending. And then you have to kind of tailor the talk for them as well, which is different when you're doing a academic presentation, okay? These people may not understand your field. Then it's always good if you're attending such conference to start with a story. For example, if you're doing cancer research, and you start with a statistic or a personal story of someone you lost to cancer, and this motivated you to do your work. It always helps to grab your audience because people are tired. They're looking at their phones and thinking about 1,000 other things. But when you grab their attention, you impress them and you will remember them, or they will remember you rather. Then I think this we already covered. Networking is very important also. Grant proposal we also already discussed. Already now you can put in your planning which grants or which funding you are going to apply for that can support your studies, and you identify those. We talked about budgeting is in very clearly identifying the cost, impact of the work. This is very important. In your introduction, your motivation, you have to clearly motivate, why am I doing this? Why do I need this funds? And also, when you're applying for a funder, look at what they fund. You have to align it with what they fund. You want to look at you want to advance the knowledge base. Are you doing fundamental research? Are you going to advance it? Are you doing applied research? Or translational research, as they also call it, that will have societal impact. It will help someone. Or as I already said, you have to align it with the priority of the funder. Very important. They will also look if you adhere to your ethics. Ne? Also that you outline if there's any risks and how you are going to mitigate this. This shows that you have foresight, you can see, you can anticipate. That is not so important. You can give, sometimes it's very important also to share your proposal with the colleagues that are on the proposal, or with your supervisor if you're applying for a fellowship, so that they can guide you and advise you on where to improve and etc. etc. So now the first one, let's look now at looking at the literature review. So some of you already attended, but I'm going through this again. So the first thing, before you start your study, you have to look at the literature. This is extremely important. What is out there? What do people do? And what is not known in your field that you are going to address? This is very, very important, okay? And you have to do this continually because there's a massive amount of research that is being published on a daily basis, and someone else may be doing the same work as you, already publishing it. So there was a case of a student last year who did a review paper, and there was someone who published a similar review, but they didn't pick this up. So the reviewers and the examiners said, okay, the study was published. Why didn't you include this in your paper, in your literature review? And it's always good to highlight this, mention that you saw the study, and how does this study or review paper differ from what you are reporting. That's important to highlight that. There's also sometimes papers that's being rejected and then they go into review process again. So always continually look at your literature. Okay, what is the benefit of this? You will prevent duplication. It will save you a lot of time. You will have easy access to information. Okay, relevant studies can provide valuable insights for you, and you become familiar with the terminology in your field. Now, always before you start looking for the information, you start with a question. You decide on the sources that you're going to use. You're going to develop a search strategy. and then you're going to keep records. Now, there's a whole lot of search engines out there, but normally you will start with journals. You want to look at high impact factor journals. Where do you look for the impact factor? You go to the journal website, you can just Google, and normally impact factors above 3 is good. You want to aim for 5 or higher, because you know that this research published in these journals are good. But always be critical when you read these journals and the papers, because sometimes people can make mistakes, editors can be biased, etc., etc. Also, when you are reading or you find that a lot of papers are being published in your field in a certain journal, you can sign up to get an email in from this journal when there is new papers being published. So on the journal's website, there will be a lot of different tools that you can use and access. You can ask to get emails to alert you to new work. Then there's different sorts of databases also. Remember, these also depend on the field that you are in. Normally, sciences will look more at Google Scholar, ISI, Science Direct, Scopus, where social sciences will also have different type of search engines, but sometimes they are combined. But now, when you are doing your literature review, it's very, very important to look not only at one search engine. Don't only use, for example, Google Scholar, because this search engine differs. Here you can clearly see, look here, the PubMed, for example, when this was initiated, the language used, the focus of the field also differs. The period of the papers covers also differ. The databases from which they retrieve them also differ. So always look at a wide scope. Don't only look at one search engine. Use the same keywords for different search engines, and then you can see you sometimes pick up a lot of different studies when you do this. And you have to do an extensive literature review to know what is out there, because you may look in Google Scholar, might not find a study that you're looking for there, where you find it in PubMed maybe. So look widely. You can also use different search engines. There's not only Google, there's Bing, there's Yahoo. And if you are in a different country, it's also important to note that, for example, if you're in China, Google won't work. Then you need to use another search engine like Bing. There's also other avenues. There's different websites. There's Google Books. So do a wide search. Also, these databases where they store papers or like social media kind of stuff like research, academia.edu, you can also access that, or you can email someone if a paper is not accessible. Remember, there's the Sci-Hub, but sometimes institutions, when you are using your institutional login, they don't allow you to access these types of sites. So be careful how you use them. If you cannot find a paper, you can always access it from your home, or you can ask the author. Sometimes you also get useful information at conferences, etc. Now, to start your search engine, you will normally choose keywords. Now, you can go through this in your own time, because we still have quite a lot of material to cover. Now, there's a difference also between keywords and a subject term. Subject terms is normally assigned by subject experts. It's someone who's knowledgeable in the terminology of a subject, and it can narrow down your search, whereas the use of keywords in a specific field is more the technical relation to the field, and this will expand your search as well. So when you read, for example, a paper, look at the type of keywords people list in their keyword section. This can already give you a kind of idea what is commonly used keywords in this field. So you can also read a couple of papers in your field and then make a list of commonly used keywords. But then one also needs to be careful, because there's also synonyms of this. Then once you have your keywords ready, then you can specify in your search engine what specific information you want to retrieve. For example, if you want studies from a specific date, you use this type of format. If you want to link certain keywords, for example, you're looking for immunodeficiency, but not HIV in the title or this in the title. You can define it like that. If you want to join certain keywords, you can use the capitalized and between them. If you look for one keyword or the other, you can also join it like that. Sometimes there's also synonyms. For example, if you're looking for stuff in osteoporosis, you won't always find all papers using the word osteoporosis because some people may use something like bone density. So look for synonyms as well. And then there's some tips and tricks when you search for information. I'm not going to go into too much detail about that because we still have a lot to cover. But for example, if you're looking for synonyms, you use this tilde symbol. If you want to look for exact phrases, you put them in quotation marks. If you were looking for words in the title within a specific website, if you're searching similar websites, there's also a different approach for this. Either this or that. Here's an example of that. So here's just different types of tips and tricks of how to search for specific things, okay? For example, if you were to use, for example, if you're building now your search and you are compiling your keywords, if you use the asterisk, for example, if you're looking for something in the education, if you put asterisk after this, this will give you like information about education, educate, or people, not people, papers with this type of words in it, okay? Remember that trick. This is also numbers, so this is just also file types if you're looking for a specific file type. Now, once you have your keywords, you can use these tips and tricks that I mentioned before if you're looking for specific things like specific dates, etc. But in, for example, different types of search engines, you also use, for example, you can use a search string. Now, this can be a bit complicated, but normally you will start very broadly. You will use one or two keywords, you will link them up. For example, you're looking for HIV and tuberculosis, and then you get information with both of those terms on. But when you want to go to a little bit of more detail, you want to narrow it down, this is how you compile your search strings. So you specify to the search engine, you will want these words or this one, but you want to link it with this type of meta-analysis or papers like this, and also words like this. This is a different type of format that's being used in ISI Web of Science, and also how they compile or how they set it up in this database. This is the format that you use. Here's some more examples. Now, I just want to give you an example. So, example, if you provide this, for example, these keywords, and you combine it like this. For example, you are now looking at work where you want to investigate what is the outputs or byproducts of vegetable waste. If you combine it like this, vegetable and byproduct, because you use both synonyms, okay? Or you want to see, okay, I want vegetables in there, I want byproduct also in there. Or the spelling can be also like this, okay, the synonym, or the synonym for this byproduct can also be waste. Then you get a lot of papers, you see. Now, if you use the keywords like this, vegetable and, for example, the country and byproduct, or you get a different set of a number of papers. If you use again like this, vegetable, and you use, for example, valorization. So this then searches for words like valorization or, synonyms of different types of words linked to that. Then you get a different set of papers. So carefully compile your keywords and also write down what keywords you have used and which search engines you have used, because you can get confused along the way. And then you can also compile for yourself, for example, a Google sheet where you summarize all of the papers, you summarize what they cover, what's their aims, what's the methodology, when was they published, in which journal, and which keywords were used. Then this gives you a nice overview for your literature review. And then you can also start using already the what is this now? Reference management tools to help you with your references. I'm not going to go into detail about this, but when you're doing systematic reviews, you also have to do a different type of approach for this. You have to mention in your keywords that you're specifically looking for systematic reviews. This can you do in your own time. Now, important, what is the difference between a systematic review and a normal review paper? So for those of you that don't know, if you look at journal articles, you will find different types. You will find the research paper, you will find the review article, and you will find other types of shorter papers depending on what the journal accepts as papers. Sorry. Now, when you're doing literature review, it's important to look for review papers and recent review papers in high impact journal. This nicely summarizes your field, and also look at how people write it. Don't just look for the information. Look at how they structure their sentences, how they write the introduction. You can get a lot of information from that. For example, what headings do they use? Then also, what did I mention? Oh, yes. So you will see that they have review papers as well. Now, review papers is just a general overview of the information that's out there on a specific topic or what has been previously been published, etc., etc. So they review the subject area or the topic. But compared to systematic reviews is almost like a research paper in a review format. So you will have your introduction where you provide why you did this review. But then what differs from the review versus the systematic review is the systematic review will have your method section. So in there, you have to describe which keywords you use, which search engines you use, and if there's studies that you didn't include in your review because they don't adhere to the dates or they don't have a specific approach to their methodology or whatever. So this is the difference between those two. And remember, your approach for searching for those will also differ. Now, let's very quickly look at research methodology. Now, there's a whole lot of research methodologies that you need to just be aware of and understand so that you can describe effectively in your work. This is the type of research design that I used, and so that the reviewers and the examiners are knowledgeable what type of study you did. Now, there's general quality categories. Of course, you get your quantitative research, you get your qualitative research. Then if you narrow it down to the nature of the study, you get descriptive and analytical. The purpose of the study, are you doing applied research or are you doing fundamental research? That is basic research to build a knowledge base. Applied research is when you use research to apply to help society to address a sustainable development goal, etc., etc. And sometimes studies can also be both fundamental and applied depending on what you are doing. Then there's also primary and secondary research. For example, primary research will be like a research paper that you publish that is in the format of the introduction, methods, results, and discussion. Then secondary research is more like your systematic reviews and your meta-analysis, where you include additional data analysis of all the studies that you looked at and include this in a systematic review and meta-analysis. Okay, just very broadly, again, the different types. I'm not going to go into that much detail, but in general, you get the observational studies, and that can be further separated into your descriptive studies. For example, if you are in medicine, you're doing a case report. So this is a novel, for example, study that you're doing on a specific case. For example, a person who responded differently to a new medication and it has never been seen in the medical area, then you report something like that. Cross-sectional studies is another division of that. Analytical studies, you also get cohort studies, case control studies, nested case control. Okay, you can read this in your own time. Then you also get experimental studies in the sciences and the medicine. Randomized controlled trials, okay, where participants are randomly assigned to intervention or a control group to assess the efficacy of a treatment or intervention. You get non-randomized trial, you get a controlled experiment, then you get field experiment. For example, in the sciences, you're going out to the field, you're doing a field experiment or a natural experiment. Theoretical studies, for example, when you are in computational modeling, or mathematics, that is also their type of work. Computational modeling is more in the theoretical fields, systematic reviews that we already covered. Now, also this type of study design depend on which field you are in. If you're in medicine, you'll also get different studies. Like, for example, these are also randomized controlled trials. These are also in medicine. You'll get longitudinal studies where you study participants over a long range of time. Further, also exploratory studies, a pilot study is a small-scale study to test the feasibility and refine a methodology. Translational research is also another word for applied research. Okay, it bridges basic science and clinical application. For example, you discovered something in the lab that can be used to improve patient care. Then there's also something like community-based participatory research, or what they call citizen science research, where you recruit citizens to collect data for you. This is, for example, when you're in environmental type of studies, okay? So all of these differ. Again, in the sciences more field, you get the applied studies, the basic, the translation. This can also link back to applied studies, computational, as we already mentioned, which is more in your theoretical work, qualitative studies, and mixed method studies, which are also now gaining popularity, where you combine qualitative and quantitative approaches. So just note that there are these different types of study design. Go and read the slides, the information on here, and if you have questions, you can get back to it. But it's important to know that these are out there, and you need to mention what type of design you used in your methodology. For example, in this pilot study, we aim to optimize the methodology for so-and-so, something like this, okay? Ethical research, this is also very, very important. So now we have now done the searching the literature, how to use the keywords, how to make a search string, and how to use different databases to gain all the information out there to get a very, very thorough overview of your work. Then we looked at the different types of studies. Now, when you're doing the study, remember, before you start, you have to have ethical clearance. Also very important when you're doing your research, for example, one day when you publish it, you have to mention conflicts of interest. For example, did you get payments from a pharmaceutical company that you were giving presentations for, or they were giving you medicine that you test? And then you need to mention this in the paper, because this can create a conflict of interest, okay? Also, when you're working with humans, you need to respect them. Also think about your data. For example, when you're doing a certain, or when you're working with human subjects or any other field, think about your sample size. Do a power analysis. Is this sample size enough to get significance or to get good results out of the study? Also do research. You have to think about social justice. Is my research, it won't harm people. It won't, cause a social injustice. Okay, this is very, very important. Also, is there a gender balance if you're working in medicine or social sciences? Why are you specifically studying males and not males and females? Then you need to motivate that. Some broad overview things to consider. This ethical principles in research start already with your research question. How you approach your methodology, your collaborators. Are you only choosing from a certain region? Is there cross, collaboration across different region? Is there social value in your work? This is important. Nowadays, research need to address the sustainable development goals. They need to help communities. The participants that you include, did they provide informed consent? Did you obtain ethical clearance? Okay. Is the inclusion of For example, incapacitated subject, why didn't you include certain people? Okay, this is very important. All things are very, very important to think about. As we said, ethics in research already starts with your research question. What is the benefit of your research? Then going down to your collaborators. What is the integrity of your partners? The institutional ethics. Is the methodology that you're using correctly? When you are getting data, are you anonymizing it? How you protect your participants if you're working with humans? How do you collect your data? How do you store it? How do you minimize data breaches? Do you share your data? Do you use the correct statistical analysis? How do you disseminate your knowledge? This is important. One day, the research cannot be stuck in a thesis. It must be published and presented at conferences, etc. So now, reproducible research. This is another big problem. So now that we've gone now through the literature review, your different research designs, and also what was this now? Ethics is important. Also, something you need to think about that is a skill is how to adhere to research reproducibility. Now, if you look at these titles, look here, power failure, small. People didn't estimate the power of the sample to reach statistical significance, and this undermines the reliability, okay? Why most published research findings are false, okay? Look at this one published in Nature. Reproducibility trial, 246 biologists get different results from the same data sets, okay? So what is replication? Replication is the way in which you record your research and also how you write up your methods. Is it detailed enough for someone else to repeat the experiment? For example, which chemicals did you use? Was this analytical grade? Was it standard grade? Where did you procure it from? What is the instrument specifications that you use? Where did the company that you bought it from? For example, the experimental conditions of your analysis. Which standards did you use? How did you optimize this? You need to clearly describe all of this. What statistical analysis did you use? What level of P did you use? Okay. Remember, replication of findings is highest standard of evaluating evidence. It focuses on validating the scientific claim, and it requires transparency of your data. This is very important. So this already starts at the very beginning. Calculate your power. If you're using a small sample size, will this be sufficient to read statistical significance and prove my aims? Be very careful also when you choose your p-value. Sometimes people choose the p-value to reach statistical significance, but in medicine this is wrong, because sometimes you have to use clinical judgment. You have to look at the clinical significance of the data, where you just look at the data with the eye and see is there differences. How will you manage your data? Okay. Sometimes in certain fields, they also request that you pre-register your plan, you publish that. Also, repeatability, also especially with your data. For example, you will make changes in your data, and then sometimes you will forget to mark a date, and then you don't know which is the most recent version. Sometimes reporting data, or there's also biases in that and how they do analysis. Data dredging is also a very important problem, hiding certain data, omitting null data, data that wasn't valid. For example, we once did a study to see, is there antimicrobial activity of nanoparticles on certain bacteria? We didn't find anything, but we published it in any case because we found that these can actually then be used as anti-cancer study. Although it doesn't have antibacterial, it can be used for cancer. Underpowered study also. When your sample size is not good enough, your experimental design is weak, you have unspecified methods, a lot of errors, etc., etc. So how to rectify this? make your data open. Nowadays also, it's requested that you publish your data in open data repositories like Figshare. The journals will also specify this when you can deposit this. But when you deposit it, your data needs to be clear to someone else. For example, mark your columns clearly. For example, if you have a date, mark the year, the month, and the date or the day so that people don't get confused. Anonymize sensitive data, okay, etc. All these things are important to think about. So I'm going now. Now that we're done with research repeatability or reproducibility, what the essence of this is, record what you are doing and report it or record it in enough detail so that someone else can go and repeat the experiment and get the exact same results. Okay, now another important point is planning your career. This is a skill that you have to learn. First, author publications is important for your career. You have to be the first author in your publication. Balance not only your experimental work, but also do training, attend workshops, learn how to communicate well, talk to people about your research. Even your family and your friends who's outside of your field can provide you with very, very good advice. Have a passion for what you do. Be a team player. Remember, if you're working in a lab environment, you need to work in the team, okay? Engage socially with your group and take care of your health. If you get stuck in your experiments, move forward. Go ask for help, find a solution. There's always a way out. Remember, communication is important. Remember, whenever you're doing a PhD or any type of study, it must represent a significant advance in the knowledge. And always when you're doing the work, have a paper in mind. You want to publish your work. Take criticism constructively. Sometimes it's difficult, but it's there to make you grow. Then when you start your project management, you want to think about, okay, by what month am I going to start this? Which month am I going to do, for example, my literature review, etc., etc. This is also important, for example, if you are your planning is very important also when you're applying for fellowships and these type of things. Sometimes they require you to include a time management plan, and they score this. They will look at this. Is this feasible? How you kind of distribute your tasks, how you schedule the time. Is there any risks? Do you include also time for experiments that didn't fail that you want to redo, etc., etc. Okay, let's move on. We already addressed that. Let me just check something here. Okay, yeah, important. Align task in support of your project. Okay, and then it's always go and check your sheet. Are you adhering to these deadlines? Sometimes things can happen. You may get ill, or there may be something happening. Then you need to include that and manage that. Okay. Gantt charts you can also use now. Let's move on now to the CV. This is important that you need to know how to write a CV for applying for academic positions one day versus industry positions. Remember, academic CVs will look at your research, history, your publication, your teaching, and your service to the scientific community. Also remember to read the advertisement and adhere to the job description. Okay, this is very important. Now, normally the CV for the industry is shorter, much shorter than the academic CV. But normally all will include your contact information, whereas the CV for the academic part, if you're applying for an academic, will focus more on your education, your research, your publications, your presentations, your awards and grants, your service that you did for the academic world, that you serve on some committee, outreach activities that you did in society. For example, you gave a lecture at school about the importance of science, research interest, your professional development activities, etc., etc. Also, depending on the field, for example, if you're in arts, did you have any exhibitions? Did you have any performances in the theater, etc.? Then for the industry CV, it's much more shorter. There, they want to look at how your experience aligns with the position, and you need to highlight this. Remember, also formatting in the CV is very important. You want to format it consistently. For the industry CV, you want 2 pages max. You want short phrases, not long sentences, bullet points, and you want to order your information in the order of relevance. You want to, very importantly, focus on your skills and keep the readers in mind, okay? They may not be familiar with the field, so you need to kind of align. You need to ask who's going to review this, and you kind of need to align it. Okay, if there's information in there that doesn't pertain to the job, remove it. But if there is, explain how it links, proofread it. We don't want any spelling mistakes, etc. in this. So where do we start? Chronologically, okay? And then we list all the past positions. I'm not going to go into detail about that. You can read it in your own time. Okay, what is the preferred qualification? Your responsibilities, okay? What is this? Okay. Just remember, when you go through these slides and when you apply one day, you have to really, really align your CV with the advertisement of the work and make it novel. Sometimes, these companies, they receive enormous amount of CVs. And if your one stands out, for example, if you have like a summary, like a visual summary on your first page about how your skills align with the job advertisement, for example, how your what skills and what is your past experiences that can very well support this. Things to avoid in CVs: unprofessional emails, impersonal greetings like dear sir, dear madam. Address the CV to a person that is going to review your work. That's why it's good to network, to get to know people, to meet people, okay? This I'm not going to go into detail. You can go through this in your own time. All the text is here. Now let's move on to leadership. Leadership skills is very important for you to learn, because one day you may lead a team, you may lead a lab, then you need to know how to lead these people well. Now, leadership can, there's different types. You get creative leaders, you get dynamic leaders, you get qualitative leadership, and then you get kind of shared leadership. One needs to kind of know what type you prefer and what type is best for your team. Then also you need also to understand yourself. What makes you happy? Are you happy in leading people? How do you engage with people? Listening to people is very important when you are a leader. Risk taking, do you have an innovative approach? If there's a problem, how can you innovate and solve this? Always when you lead, also you need to have a vision, and you need to anticipate for things that can go wrong in the future. How is your network? You need to think about that also. Self-awareness, okay? Also, resilience. That's very important. Things can go wrong, and then you as a leader need to be strong enough to carry forth. Now, in higher education, there's various aspects that can affect your leadership style, the organizational structure, sometimes interpersonal factors, etc. But it's important in general to develop these skills. So develop your communication skills when you want to become a leader. Conflict resolution skill. This is a skill not taught, but it's very, very important to learn this. How to self-regulate, how to empathize with your people, because sometimes your team members may be ill, they may be going through some personal challenges, they may not be performing as well. And then you need to empathize with that. What is your academic capacity? If you don't have a skill, it's not a strange match, you can learn it. You need to build your community service skills, how you interact with communities. How can you align the work to build and help communities? Do you have resources? Do you have knowledge in a specific field that you're going to lead? What is your management skill? Because leadership is often tied to managing a group. It's not only leading a group, but managing them as well. So what is the basic skills you need? You need integrity. This is very, very important. You need to be principled. You need to treat others as they wish to be treated. You need to be passionate about your belief, and you need to persevere when the going gets tough. This is important. Vision. Have a vision. Okay, where do you see your group or your work leading to one day? This is already now at this stage of your career. When you look at your research, don't just do it to get an M or a D. You have to have a passion for this. Where do you see yourself going with this? Is there a future in this? Will it be publishable in 10, 20 years? How are you going to innovate it? How you can build it out multidisciplinary? This is all very, very important. When we have a vision, it kind of creates meaning in the life of the people that follow you, okay? Also, communication, this is very important. Sometimes leaders don't listen to the people. You have to make time to listen to your team members, okay? This is very important. And also how to share information well. How do you communicate? Do you want to schedule meetings one-on-one? Are you going to schedule a meeting online, which is best for your style, and what also do your team members prefer? Think about also, do you communicate with your person as well as with words? How do you handle confidential information? This is all skills. How you develop people. Remember, this is very important. When you are a leader, you are responsible for the people that are working for you. You need to encourage them. You need to help them. You need to mentor them. One day, when you are a supervisor, you need to help your student and see that they become the best researcher possible. Then, what are the leadership skills that you can already now learn at this level? So you facilitate group discussions, right? You will conduct meetings where you can lead this. You learn how do you appropriately respond to positive or negative feedback. You learn how to collaborate on projects if you're already collaborating on various projects. You can learn how to mentor already. If you're a PhD, you can mentor someone who's busy with a master's degree. You can learn what are valuable skills a mentor needs to have and also a mentee needs to have. You can already start now motivating others around you in your lab to complete their projects. You can teach skills or concepts to others. You can learn how to navigate complex bureaucratic environments. For example, in your type of environment, for example, you can learn already, for example, if you want to procure chemicals, how is this done? What is the financial procedures so that you can lead such things well one day. Then remember, leadership and management is very much interlinked. So if you're a good leader, you also need to be a good manager. This is very, very important. So let's look at what is the SMART goal of being a good manager. You need to be specific, clear, and detailed objectives, which is significant if achieved. It needs to be measurable, your goals. The team needs to agree to this. Remember, the plan need not only be yours, but it needs to align also with the vision of your team. Can it be included or completed in a realistic time frame? What is the desired result? What is the complexity, etc., etc.? Organization is very, very important. Are the right people involved for the right tasks, and do they understand their roles? Is the timing coordinated, etc.? Basic management skills also, you want to direct people. So once the planning and organization is completed and the project begins, the role of the manager turns to orchestrating flawless execution by and of people, systems, and timings. Remember, if you want to be a good leader, you also need to learn management skills. You want to monitor also the project. This is something you can also learn now already. You track your progress. If there's problems, how you're going to troubleshoot it, or you're going to tweak your experiment or your hypothesis to address this concern, how you motivate and encourage yourself. These are all skills that you can already No, learn now. So what can you learn now? To work effectively under pressure, set yourself a deadline, okay? Adhere to those deadlines, okay? Comprehend all the new material and the subject matter quickly, okay? Get all your papers, read them, learn how to critically read papers. This is also very important. We had a previous session on this 2 weeks back. When you read a paper, normally you will first look at the title. Is this relevant to you? You will look at the abstract, but be careful. Sometimes people don't always include all the information pertaining to the article in the abstract. But then you read briefly through the paper as well. Normally you can read the aims quickly to see, okay, is this worthy for me? Then you will have a look at the methods, what type of methods they use. And if you decide, okay, this paper is not for you, then you can move on to the next one. But if you decide now, this paper is for me, I can read this, then you group the list of papers that you want to read, and then you critically read this information. For example, you will look at who is the authors of this paper, who is the journal, in which journal is this published. You look at, for example, you go to the journal website, you look at the impact factor, you look at what type of journal or what type of work this journal publishes, multidisciplinary or just singular disciplinary work. You look at how they write the abstract, the format of this. You will look at how they write the introduction. And you don't just look at it for information. You look at the writing style. How do they introduce the study or the importance of the study and what is missing and why they addressed and how they address these missing gaps. You will look at how they formulate the aims. How do they write this? Then you look at the methodology very critically. What techniques did they use? How did they describe their methodology? How did they formulate the different or which different headings they use? How do they summarize the chemicals that they procured? The experimental analysis, what do they include there? The pH, the type of instruments they used, the experimental setup, what standards they use, how they selected controls, why they didn't include certain controls, and important, the statistical analysis. Can you hear me? Someone said I'm not audible.
No, we can
Sorry?
hear you loud and clear.
Oh, that's okay. Okay, that's fine. Now, also, where was I now? Okay, you look at the methodology, also how they describe the statistical analysis, okay, which groups they analyze. Sometimes it's very important not to just say, okay, I performed a student t-test. You have to describe. I used a student t-test to compare group A with group B using statistical significance level, this and this. Then you go to your results section. You read the paper. How do they report on the results? How do they summarize the results in the figures and the tables? Also, which legends? How do they describe the table content? Look at how they write the table heading, okay? You learn from that. And the discussion, that is very critical. This is where you really learn how to discuss a paper. Don't look at just information. Look at the first paragraph. How do they write that? What type of papers do they include? How do they discuss what type of result they obtain? Does it support the literature? Doesn't it not support the literature, and why? How do they write their conclusions? Some people make this mistake. They only summarize everything and they don't really conclude what the implications and limitations of the study and what future work we'll be looking at. Now, be careful, because if you include future work, write it in such a way that someone else won't take your ideas, okay? But for your thesis, it's important that the examiners can also see that you think forward. Okay, I did this, but I couldn't do this and this, but I will address this in future research, okay? That shows that you critically thought about your project. Then you will learn how to manage your project well. This is very important. You put up the Gantt chart. You will put in deadlines for yourself. By this and this date, I will complete my literature review. I will do my experiments. Maybe there's something wrong that went wrong with my experiment. Then I add an additional month. I plan, okay, I will use this to repair the experiment or get the chemicals or whatever, when I will publish, etc., etc. Then also identify or think about a project that you can complete in the time. This is also important management skill. That you don't do something that you cannot complete in the specified time. Prioritize urgent tasks and remain flexible. There's some comparison between the two. Okay, I'm not going to go into detail about that, but okay, let's go through this. Let me see if there's something important I should mention to you. Okay, just the difference between the two, but remember they always align. When you lead something one day, you have to have a vision, okay, but you also have to think about you want to build something, okay? As a leader, you need to define the purpose of this work. As the manager, you need to kind of nurture the organizational structure. As a leader, you create the mission statement. As the manager, you want to deliver on that. As a leader, you want to evaluate strengths and the needs. As a manager, you organize your team, you plan your budget, you set the timelines, and you maintain the quality. As a leader, you want to inspire people and you want to commit, you want to foster commitment. But as the manager side of the leader, you want to develop talent, solve problems. Okay. Remember always that when you lead, you need to manage as well. And then you'll be a very good leader. Okay. There's some more details that you can go through in your own time. Remember always now, also already now, you want to say thank you to people, because if you are kind to people now, you may run into someone 10 years along the line, you didn't treat them very well, and this may come back to you. So already now you learn how to say thank you very much. You acknowledge help. Okay. You want to share information. Okay. Also, if there's maybe a paper that you find that may be relevant for a colleague, you help them, you share it with them. Okay? Inspire the people around you. Already learned the skill now already. Okay? Have fun. Enjoy when you're working in your team. Learn how to work well in a team as well. Okay? Learn to set small milestones for yourself. This is already skills you can start learning now. Okay? Give feedback. This is very important. And you can learn also by now already starting mentoring. For example, if you're a PhD student, you can mentor master's student. You learn also, if you review, for example, their writing work, you can learn a lot from reviewing other people's work by giving feedback. You learn as well. So I'm not going to go through that exercise. Very importantly, one day when you lead, you will need a team. Okay? And high-performing team members is important for your team. Sometimes people have diverse personalities. Okay, this is important to think about that, but they all need to be committed to the unified goal. They need to be accountable. There needs to be open communication. Sometimes there's dysfunction, etc., etc. Now, I'm not going to go through too much detail in conflict resolution, but just to give you an example of a conflict that I personally have experienced recently, and it was a very, very difficult situation. So what happened is I submitted a paper for publication, but then towards the end of the publication process, one of the authors wanted to be corresponding author, and the person went to email the journal and they insisted they be corresponding author. And this is a kind of a powerful person, but it came to my attention that all of this happened behind my back. Now, this person was very angry when I refused to put the person as a corresponding author because he felt that, he wants to be. Now, in such a situation, when someone shows aggression, it's just best to keep quiet. Don't say anything. Sometimes it's also good to understand where the person is coming from, their history, what formed them to be like this, to control. Sometimes people have controlling type of behaviors based on situations they faced in the past, and this forms them as a human being. So also have an open conversation, explain why the decision was not made, that this needs to be discussed at the very beginning, and one cannot preference one author above the other. So there needs to be open communication as well. This is very, very important. What else? But be careful how you communicate also, because sometimes people can use your arguments even against you. So be very, very careful what you say. But open communication is very important. We still have sometimes, so we can go through this very briefly. If the situation is very difficult, you can always involve the university ombudsman. But normally, if there's friction between people, always assume good intentions. When you're a leader one day, listen to both or the different parties. Each one is coming from a different angle. Sometimes people have my difficulties in their personal life, then they may lash out, and you may not know about this, and then this may create friction. Be open to change. Sometimes conversation is very important. Always follow university processes, etc., etc. But open communication and handling the situation with kindness and respect for all peoples involved is very important. This you will learn as you go along. I remember another situation that I also faced. I was bullied by my postdoc supervisors, and it was a very traumatic event actually. But in the end, I kind of understood where they were coming from. They were in the process of being retiring, and I was supposed to take over their responsibilities, and they were not happy with it. They were not really ready to retire because they were extremely attached to their work. So this bullying was happening to kind of push me aside. Now, when some things like this happen, you have to kind of understand where the other person is coming from to understand the situation is a bit better. Then involve senior colleagues that you trust. That's also very important when you are still young. Have a senior person that you trust, that can mentor you, that you can go to for advice. How do I handle this sensitively? Don't get angry, don't get negative. There's always a way out, but try and understand also where the other person is coming from. Handle it with respect, kindness, and open communication. Now, let's move on to handling rejection. A lot of papers will get rejected, funding applications. This is a process all of us go through. It's important for you to kind of, deal with it, but not too long. Process it and then move on immediately. For example, if you get a paper and there's a whole lot of comments in there, it's very negative, you don't want to dwell on this. You want to take time to recover, not too long, and then the next day you go back to these comments, you grab yourself a chocolate or a coffee or whatever helps you, and then you go through this systematically and you start with the revisions. Okay, this is very important. You have to have resilience in research. Also, when something goes wrong, when it feels like, oh no, everything will go wrong. For example, this happened to me in my PhD. I did a study on plants and microbes, and one day they decided they want to clean the greenhouse, and I had to move my stuff out, and the next day they were all contaminated with ants. And it was over 200 plants. It was absolute disaster. I was at the end almost, and I felt, oh my, this is an absolute disaster. I'll have now to start from scratch, and I was already in the third, fourth year. But then I devised a kind of plan. How can I adapt this work to just only work on a couple of plants, and how can I adapt kind of the work to get what I want? Because some of my results also didn't work out. And then I went to papers. I read a lot of papers, and then I got a lot of ideas, and I kind of adapted the work to make it work eventually. Also, it's very important in your career to take very good care of yourself, exercise, and all of these things. Remember also, I mentioned this example about the Nobel Prize winner. He got even his paper rejected. And even I remember at one stage in my career, I was having a lot of difficult issues. I came across this book Sometimes it's good to go and read inspirational journeys of other people. You can really, I mean, there's people out there that has really been through a lot and they achieve success no matter what. So go and read these inspirational stories. Now that we're done with this, we have a couple of minutes left. I'm going to give examples. You can go through this in your own time, but we're going to discuss some examples of thinking. You can go through this in your own time. Let me just check if I covered everything. Okay. Remember, it's important for you to develop your strategic thinking skills, and this can also be further stratified into how you analytically think about things, how you solve problems, how you critically think about your work, how you forecast. For example, would there be complications with my work? How will I adapt? Or will my research still be interesting, 10 years down the line? How will I adapt it? Okay. I'm not going to give so much detail about this. How do you improve this? It's very important. Remember, if you are planning on developing your strategic thinking skills, you want to ask strategic questions, you want to consider opposing ideas, you want to attend workshops also to development. To develop this, you also want to create a strategic mindset. How do you do this? Okay, there's different types of reasoning strategies that you can also use. I'm not going to go into this. Critical thinking, again, is very important. We already discussed some of this. And this is general term given to a wide range of cognitive and intellectual skills needed to effectively identify, analyze, and evaluate arguments. Remember, you also learn how to write argumentatively in your writing. This is an important skill to learn, etc., etc. Now, critical thinking, as we said already, starts at the real beginning of your work. For example, how you collect information. For example, you need to critically think, is this websites or search engines that I'm using right for my search, for my research area? For example, think about the keywords that you use for your search, etc., etc. Also, when you're looking at your data, when you analyze, do you critically assess the data? What different statistical analysis can you use? Also think about how you're going to communicate your work, okay? Think about already now that you're going to publish the work and you're going to do this at conferences and you're going to publish it in journals. Then, why is critical thinking important? I'm not going to go into that much detail, but let's look at the standards of critical thinking. You want clarity, okay? You want to ask questions. Could you elaborate a bit further on that point? Could you express it in a different way or give you an illustration? You want clarity. If you don't understand something in your research, you need to ask questions. When you look at your data, okay, think about, is this really true? How can I recheck it? How can I find out if it's true? Look at your statements that you're making. Is it accurate? Sometimes people make a lot of mistakes. They report on their results and then they interpret it in a certain way, but it's not accurate. It's not true according to the literature. So check that. Precision also, look at that, okay? Provide more details in your methodology so that someone else can go and repeat your work. Okay, relevance is also important. What do you write? For example, if you write in your literature review, sometimes people include a lot of stuff in the literature review that is not relevant to the main question, okay? They will include a lot of background detail that's not really relevant to the aim of the study. This is important. Do you provide enough depth in your work as well? How does your answer address the complexities in the question? How does your data address your aims? Okay, these are things one needs to think about. Also, the breadth. Look at, for example, your work. Do you need to consider another point of view? Can you ask your research question in another way? Is this the best possible way? Your title also, does it encompass your whole study? How can you include the breadth of that? Is it okay? Logic, also look at your data, the analysis, does it make sense? Okay. Fairness, that's another important point. I'm not going to go into that. not that. I want to get down to the examples. So here are some examples that you can go through, but I want to focus on the strategic thinking. So here is some examples of that we'll briefly go through. And then this was one last you can go through in your own time. So let's look at the strategic thinking. So what is this? How do you strategically think? Now, here's an example. An honest student is planning a research project. So instead of jumping into experiments, they map out long-term goals, identify funding sources, consider collaborators, anticipate obstacles, and design a timeline that aligns with their graduation. Now, this is very important because this person is strategically thinking. They're seeing the bigger picture and aligning short-term actions with longer-term goals. So this is a good example. So as we said, when you start your research already, plan your work, okay? Can I apply for funding for sources to get to fund my studies? Are there the chemicals available in the lab that I need? Are the techniques or the methodologies or the instruments available? Who can help me? Who can mentor me? What obstacles will I have? Maybe my experiment won't work. Then I need to budget for time for this into my Gantt chart, etc., etc. When will I publish my work? In which journals? Will this journal be better than the other one? Is multidisciplinary? Now let's look at this example of analytical thinking. A student compares two data sets on bacterial growth under different pH conditions. They use statistical analysis to find significant differences, examine possible sources of error, and conclude with condition optimally supports growth. Now, the skill highlight here, you analytically think. You break down the complex information into components, and then you identify the patterns or the relationships in your data. Is there correlation? Can one variable predict another? Is there confounders in my data that can influence the outcome of my statistical analysis? Let's look at creative problem solving. Faced with a limited access to a specific reagent, the student devises an alternative protocol using locally available materials that still produces reliable results. Now here, one thinks out of the box to develop novel or unconventional solution. Critical thinking, another example, we're almost done. When reviewing a published paper, a student questions the validity of the conclusions, examines the methodology for bias checks, data consistency, and suggests that further experiments are needed to strengthen the claims. What is the skill highlighted here? The critical thinking skill is to evaluate the arguments and the evidence logically and independently. When you're reading the papers, also check, does the data support the aims? Okay. Forecasting, this is very important. A student anticipates how changes in climate patterns may influence the spread of vector-borne diseases in their region over the next decade. So they are predicting future outcomes based on current and historical information. Adaptability, this is also a skill that's important. For example, during a field trial, you are there, suddenly begins to rain, disrupts your data, and the student quickly redesigns the methodology to collect different but still valuable data under the new conditions. So this adjusting strategy and solutions in response to changing conditions or unexpected obstacles. Now, let's look at problem solving. We'll do one example here, and then one in the social sciences, and then we can conclude. So let's look at this example. Let's look at. Okay, so let's look at this one here. A PhD candidate working on developing nanoparticle-based antimicrobial therapies encounters inconsistent experimental results regarding nanoparticle toxicity profiles and the antimicrobial efficiency. So despite replicating protocols precisely, some nanoparticles exhibit high antimicrobial activity but inconsistent cytotoxicity patterns. So how is this person going to solve this? So first one needs to identify what the actual problem is. Okay, so The initial observation was that the nanoparticles synthesized using this protocol display very cytotoxic results between batches, while antimicrobial efficacy remains consistent. So then we define the problem. What are the underlying reasons for batch-to-batch variability in cytotoxicity, but consistency in antimicrobial efficiency? Now we want to analyze it, okay? We want to use different techniques to analyze the samples, and we have findings from the analysis. And this showed us certain trends in the data, and then we formulate the new hypothesis, okay? Then we design the new experiment to test the hypothesis. Then we again implement and evaluate the result, and then the problem is solved. And then we reflect and disseminate, okay? Let's look at this example quickly here of the social sciences. This is a PhD candidate. They conducted qualitative research on the experiences of immigrant integration in urban contexts, and it encounters significant discrepancies in interview responses. Some participants provide positive, others share very negative, despite living under same socio-economic conditions. So now let's identify the problem first. We need to know, what is it? Why do immigrant participants with similar background present fundamentally divergent experiences? Then we analyze it. We review and analyze the review or the interview transcript systematically using thematic analysis and narrative analysis techniques. You map demographic factors, immigration history, social networks, and emotional narratives, because we have to critically think. The persons giving the negative account may not have a strong social network. They may come from a different region. They may have a different psychology. Then we summarize the findings. We formulate a new hypothesis, and then we design research to test the hypothesis. We implement, and the problem is solved. Okay, so this is all examples of thinking skills. So I'm going to conclude for the time being here. This you can go through in your own time, because I see we're already over. Creative problem solving is also very important. For example, we had an example there. If you run into problems, then it's important to solve them creatively. Also, last point before we conclude, emotional intelligence is very important. Self-awareness, self-regulation. That is related to how you resolve conflicts. Don't get angry quickly. Social skills is very important. Having empathy with one another. Now, very important, sometimes people in the lab compare themselves. They will stress, oh, this one is already publishing, this one's experiment. Don't compare yourself with others, okay? Forget the competition, focus on yourself. Remember, our bodies can change our minds can change our behavior, and our behavior can change our attitude. That is why attitude is very important. When you come in the lab, you want this to work. It will rub off on your work, okay? This is just a summary of what we discussed. And if you have any questions, then you can ask me. I think I'll stop there for the time being. Thank you so much for your attention.